Hi, I'm Ms. Cho with Lesson 3.12, Linear versus Exponential Situations. Our aim is, how is a linear function different from an exponential function? And our lesson objective is, I can determine if a real-world situation is linear or exponential by looking for keywords. Before we look at situations, let's review what we know about linear and exponential functions. When we look at the graph of a linear function, it's a line that goes up or down. We've learned that linear functions add or subtract the same amount for each interval, so they have a constant rate of change. And this is changing by addition or subtraction. Whereas with exponential functions, when we look at their graphs, they go up very steeply or they fall very steeply and then slow down. And from Ms. Gunter, you learn that they're changing by multiplying the same amount for every interval. The x's change by a constant amount, but the y's are multiplying or dividing. We've also learned from Ms. Gilbert that when you're looking at a word problem, you want to find the rate of change and the initial value. For this lesson, we don't really need to worry about the initial value. We're just going to focus on the rate of change. We're actually going to take this one step further and decide if our rate of change is addition or subtraction, or our rate of change is multiplying or dividing. If our rate of change is changing by addition or subtraction, this is linear, and if it's changing by multiplication or division, it's exponential. When we have a linear rate of change, we're going to have a number per unit. So for example, this is going to be something like 25 miles per hour or 3 days per week, something like that, where you just have a straight up number. In exponential rates of change, you also have something per unit, but this is not going to be a number, it's going to be a multiplier. And we have some keywords that can help us out here to figure out if this is a multiplier, where it's like double, triple, quadruple, halves. So these are all number multipliers, double meaning 2 times something, triple 3 times something, quadruple 4 times something, half times something. So for example, the zombie population doubles. We also have keywords like percent, like the resale value of your laptop declines by 20% per year. Or we have a factor of, so sales are growing by a factor of 1.7 times per year. So all of these are multiplication indicators, are keywords that we can use to help us decide if this rate of change is exponential. So when you look at a word problem, you want to ask yourself 2 questions. One is, what is my rate of change? Again, these are keywords like rate, per, each, and every. Once you've figured out what number represents your rate of change, you want to ask yourself, is my rate of change a number or is it a multiplier? If it's a number, then this is a linear rate of change. And if your rate of change is a multiplier, you have an exponential rate of change. Let's take a look at some examples. Here we're being asked to identify the rate of change and whether each situation represents linear or exponential change. I'm going to just write my questions on the side to remind myself. So first, what is my rate of change? And 2, is my rate of change a number or is it a multiplier? So as I look at the first example, it says Dante has seen 84 episodes of Dragon Ball Z and he is watching 3 episodes per day. So my rate of change keywords are rate, per, each, every, and I see a per, which means that my rate of change is going to be my 3 episodes per day. My second question, is the rate of change a number or is it a multiplier? I see it's 3 episodes per day, so this is just a number, which tells me this is a linear situation. In my second example, it says there are 2 million rats in New York City and their population doubles every 10 months. This is not a real fact, I just made it up, so it's just an example. All right, so my first question is, what is my rate of change? I see looking for keywords, and I see the word every, And so 10 months is my unit. This is my period of time that I'm measuring. And I don't see a number, but I do see a keyword double. And so my rate of change is that the population doubles every 10 months. And as I'm asking myself, is this a number or a multiplier? Doubles means 2 times, so this is a multiplier, and this tells me this is an exponential situation. Let's try 2 more. In our third example, we have my grandpa has 50,000 hairs on his head and loses 20% of the ones he has left every year. I'm looking for keywords for rate of change, and I see the word every, so every year, and my rate of change is 20% of the ones he has left every year. I'm not going to recopy that just for the sake of time, but I want to know if my rate of change is a number or if it's a multiplier. And I see the word 20% of, so this means that I'm multiplying 20% times however much hair I have, or my grandpa has. Because this is a multiplier, this tells me that this is an exponential situation. Finally, we have Kayla has saved $120 and earns $10 per hour babysitting. So I see the keyword per hour. So this tells me my rate of change is $10 per hour. And is it a number or is it a multiplier? Well, this $10 is just a number. So this tells me that this is a linear situation because every time I add an hour, I'm going to make $10 more. Let's summarize. So linear situations change by adding or subtracting a constant number. Exponential situations change by multiplying or dividing by a constant factor. To figure out how to classify a situation, you want to ask yourself, what is my rate of change? These are keywords like rate, per, every, and each. And you ask yourself, is my rate of change a number or a multiplier? Multiplier keywords were things like doubles, halves, triples, percent, or factor. And if you have a multiplier keyword, this is an exponential situation. And if you have a number as your rate of change, this is a linear situation.